This will be for the con exercise, model with composite functions. All right, it says oil is leaking from a damaged shipping vessel stranded at sea. The captain estimates that the cost C in millions of dollars to clean a ton oil spill can be modeled by this function. Okay, that's C of T. The amount S of oil in tons that has been spilled in D days is given by the function right here, S of D. Which expression models the cost of cleaning up a D-day oil spill? So this function C of T is the cost in terms of tons. Okay, where T represents the number of tons. But how do we find out how many tons of oil are actually spilled? Well, that's right here. S is the amount of oil that's spilled in tons. Okay, but S is written in terms of days. So really, since this gives us how much oil is spilled in tons, I think we can just take this function and plug it in right there. Okay, so what we're really looking for, we're looking to find, instead of C of T, we're looking to find C of S of D. Okay, because S of D will give us T. So we want to plug in the expression for S of D in place of T. All right, so that's what I'm going to do. I'm just going to take this expression and plug it in place of T. Okay, so we have 1.5 times T, which is 355D, and then plus 2. Close the parentheses and then plus 2. So that's it. We just have to multiply 1.5 times 355. So I get 532.5, and that is still times D, and we still have plus 2. So that is our final answer, the expression that we need. 532.5D plus 2. Let's take a look. Okay, 532.5D plus 2. Right there, it's answer D. All right, it says Carter plays on a football team. He modeled a few relationships. And it says the expression N of W of X represents which of the following? Okay, I'm going to try and get the answer before I look at my choices. All right, and just so we're clear, the input is typically the X value, and the output is typically the Y value. Okay, I'm not sure that matters too much for this one. Let's take a look. W of X, it says right here, that is the winning percentage, okay? And the X is the average daily practice time. So W of X is the winning percentage in terms of practice time. So I'm going to write that out. Okay, in place of W of X, I wrote win percentage in terms of practice time. But what does N represent? N, the output for N, is the average number of fans per game. So since this is an N function, it's going to be the average number of fans per game in terms of practice time, okay? Because we got the winning percentage from the practice time. And N is going to be the average number of fans per game in terms of that practice time. Let's take a look. Okay, so looking at my answers, answer C, the average number of fans per game as a function of the team's average daily practice time. Okay, so N was a function of W of X, but W of X was a function of X, which is the average daily practice time. So N became a function of average daily practice time, since this was based on average daily practice time. Okay, Denise studied the park near her home where she saw and modeled the following relationships. All right, we have B, H, and T. Which two of the following composed functions make sense in this context? All right, let's see. H of T of R, let's see if that works. Okay, H of T of R, let's see. H would give us the height of the tree. And if we plugged in T of R in place of K, let's see if that works. T of R is the average temperature, and K is the average temperature. So we can certainly take T of R and plug it in for K, and then get the function H. So that one works. Okay, H of T of R works. Next up is H of B of R. Let's see. Okay, H of B of R. R is the altitude of a specific location. But the function B is the number of birds based on the height of a tree. So the altitude of a location and the height of a tree are two different things. Okay, so you can't use R for the B function, because this function is dependent upon the height of the tree, not the altitude of a specific location. So that one does not work. All right, let's try answer C, T of H of K. Okay, T of H of K. H of K is the height of a tree at a certain location, and T is the average temperature. And T is based on R. R is the altitude of a specific location. So you can't take the height of a tree and plug it in for altitude. Okay, so that does not work. This is altitude of the location. This is the height of a tree. It's different. Okay, finally, B of H of K. Let's hope that works. B of H of K. Well, H of K is the height of a tree. The B function is the number of birds based on X, which is the height of a tree. So you can take H of K, which is the height of a tree, and plug it in for X, because that is the height of the tree, and you'll get the B function. So that works. So answer D is also correct. So we have A, we have D. It said two answers.